The following is example 3, or D3, from your midterm review. And this is dealing with volume, so we're asked to find the volume that we get by revolving this shape here around the x-axis. And we're asked to set up the volume using both the washer and shell methods. So we want to use both methods and then solve one of them. So we'll start with the disk method. Disk or washer, whatever you want to call it. Same method. And in order to solve a question with this method, we need outside radius, inside radius, and thickness. So we need our rectangle. For the disk or washer method, the rectangle is perpendicular to our axis of rotation. So here's our axis of rotation, meaning we need a dx rectangle. So the outside radius then is the distance from our axis to the curve. Now since we're using both methods, one's going to be dx, one is going to be dy. I'm going to solve these equations. So this one's x equals y squared, or y equals square root of x. And this one's y equals x squared, or x equals square root of y. So we have them written both in terms of x and y, since we'll need both. So for dx then, we need everything y equals x. So the top of the rectangle is this curve, which is y equals root x. So this is root x. The bottom of the rectangle is y equals x squared, so this is x squared. The thickness is dx. So our volume is then going to be equal to pi times the integral, and we're going from 0 to 1, because this point is 1, comma 1. So from 0 to 1 of root x squared minus x squared squared. And that's the equation for the disk method. Outside radius squared minus inside radius squared. For the shell method, now we need parallel rectangle. So we need a rectangle like this. Now we're spinning like this. This is now dy. So for shell, we need radius, height, and thickness. Thickness is dy, because we're using a dy rectangle. Radius means the distance from the axis to the rectangle always corresponds to the thickness. It's in the y direction, so y. The height is the right side of the rectangle minus the left side. So in this case, that's root y minus y squared. Root y is this curve, y squared is this curve. Notice dy, so here we have in terms of y, this was dx, so everything is in terms of x. The volume then is 2 pi integral from 0 to 1, the y coordinates, 0 to 1, of y times root y minus y squared dy. So there's the integral set up using the shell method. Both methods will give you the same answer once you solve them now. So for part B, you have to solve one of them. For practice, it wouldn't hurt if you solved both, but I'll just show the steps for one here. Let's say we decided to solve the disk method. Then it would be volume equal to pi times the integral from 0 to 1 of x minus x to the 4 dx. Simplify first. It's going to be pi times x squared over 2 minus x5 over 5, evaluated from 0 to 1. And if you solve that, you get 3 pi over 10 units cubed. Now if you chose to do the shell method, you'd also get 3 pi over 10 units cubed. We're still talking about the same shape we're generating, so the volume of the shape stays the same. the method we solve doesn't affect the answer.